problem 1885, count pairs in two arrays. So given two arrays numbers 1 and numbers 2 of size n, we're going to count the pairs of indices I and j such that I less than j and numbers 1i plus numbers 1j gonna more than numbers 2i plus numbers 2j. So let's just use the first example to check what is the meaning. So for example, at this position index 0 and index 2, numbers 1, 0 plus numbers 1, 2 is going to be 4. And here, numbers 2, 1 and numbers 2, 2 is going to be 2. And 4 is more than 2. So this is one of the pairs. So we're going to return 1. And we cannot find any other pairs. So if we solve the problem in brute force, definitely we're going to use the two for loops, and then we're going to check if it meets the condition of this formula. Yeah. So it's going to be n squared for the time complexity. So let's just check what is so n is 10 to the power 5. So this means it is not possible. Maybe we can solve the problem by n log n time. Yeah. So here, what we are giving is just that formula. So numbers I plus numbers 1i plus numbers 1j, yeah, gonna more than numbers 2i plus numbers 2j. So for this formula, because inside it, we're gonna need to use the two indices, so numbers 1i and j. So what if we just use one index, if that is possible? Yeah. So we're gonna turn this array into this. So numbers 1i gonna minus numbers 2i gonna more than numbers 2j minus numbers 1j. Why are we gonna make it like this? Because in this way we just enumerate one index instead of two indices. So for I and j there are two indices, definitely we need to use two for loops. But here we just use one index. So this means we can solve the problem maybe using n log n time or O n time. Yeah. Now what are we gonna do? Numbers 1i minus numbers 2i, because it is in the same position, so we're gonna define it as diff I. And here, numbers 1j minus numbers 2j, we're gonna define it as diff. Yeah. So this is gonna be the minus diff j. Yeah. So if diff I and diff j, it is okay, but here is a negative value. So what are we gonna do? We still need to turn this formula to diff j gonna more than negative diff I, because it is symmetric. So for example, from the two sides, we're gonna times negative 1. So this times negative 1, so it's going to be diff j, and less than going to be more than negative diff I. Why are we going to make it like that? Because we're going to combine the two arrays as numbers I minus numbers 2i, numbers 1i minus numbers 2i. So what's going to happen? Yeah. So let's just check. So I'm going to prepare a new nums, which is going to be a sorted of. So why I gonna make it sorted? Because I'm gonna use the boundary search to find the final answer. It's gonna be a sorted of n1 minus n2 for n1, n2 in zip of numbers 1 and numbers 2. Yeah. Now I want to check what is this nums. Why we gonna why we gonna get this kind of formula? Because we're gonna use the boundary search. Yeah, so here I'm gonna return a random value which is gonna be 0. Let's just check what is this nums after sorting. So here we can say after sorting, this nums is gonna become negative 1, negative 1, 1, 1. So this is really important for us to solve the problem. Yeah. And let's just check this formula. It's gonna be the diff j. So this is the diff actually. So this is the diff array. So it's going to be the diff j more than negative diff I. So can we find it? So if we find a value diff j more than negative diff I, so after that, because the array has already been sorted, so after that, all those j, such like such as j plus 1, j plus 2, gonna always meet the condition because this array has already been sorted. Yeah. So let's just check the first value. It is a -1, and this is I, and if we give a negative I, it's gonna become 1. So from the right side, can we find a number which is more than 1? No, we cannot. What about the second number? No, we cannot. What about this number? 1. And we're gonna give a -1. From the right side, can we find a value which is more than -1? Yes, this one is more than -1, so this is a 1. And what about the last one? We give a -1. From the right side, can we find a value more than -1? No, because there's no numbers. So how many pairs? It's gonna be 1. So this is our final answer. Because we just needed to, first of all, we just needed to turn this number into a negative number. So this negative number, we're gonna turn it into a positive number, and this one gonna turn it into a negative one. And then from its right side, we have to check. We cannot check it from this number. We have to check it from the next number. Yeah, this is really important. So let me make it clear. So for this number 1, we're gonna check all the numbers which is gonna be more than this -1, but we will not change this number. It's gonna still be 1. If we don't change it, if we search it from here, we're gonna find 2 numbers. Actually, we're gonna search it from the next number. Yeah. So this is a little bit of trick for binary search. Yeah, because we're gonna turn this number into a negative. We will not count this number 1. We're gonna count the next number 1. Yeah. Now I think it should be clear, and we just need to finish the coding. So we're gonna prepare a 0 for, yeah, let's just check n gonna be the length of the nums for I in range n. So result gonna plus equal to, here we're gonna use the bisector right directly, and for this nums. And we're gonna check this number, which is gonna be the negative nums I. Yeah, according to this formula, it's gonna be the negative nums I. And here we're gonna need to prepare a low index, which is gonna be starting from I plus 1. It's gonna be the next one. Otherwise, it's gonna be wrong. Now we're gonna return the final result. Now let me just run it to check if it works. No, it didn't. Yeah, because we needed to use n minus this index, otherwise it didn't work, right? So now I think we've solved it. Let me just run it and submit it. Yeah, as you can see, it works. Let me just explain why we're gonna write this formula n minus the bisector right. Maybe I didn't explain it. I still need to explain a little bit. Let me just use this nums. Yeah. So here we have this nums, and it is -1, -1. And what we're gonna do for this number 1, we're gonna set it. We're gonna use a -1, and from its right side, we're gonna check how many numbers. Yeah, we're gonna check the number which is gonna be more than this number. By using bisector left, it is going to be the first number, but for the bisector right, it's going to be the first number, which is going to be more than -1. So this is why we're going to use the bisector right. For bisector right, we find the index. So for example, this index is 3, and we still need to calculate how many numbers. So it's going to be n going to be 4. 4 minus 3, it means that there's going to be 1 number. So this is why we're going to use n minus bisector right. And we also need to set a low index. It's going to be starting from I plus 1 instead of I, otherwise it's going to be wrong. So for example, if we set the low, if we don't set this low, it's going to be wrong. Yeah, as you can see, it is wrong. So it has to be the next one, because from the current index, we already set it to a negative value. So it is not included. It has to be the next index. So it's going to be starting from the next index for the binary right. Yeah, now as you can see, it works and it's pretty fast. And the time complexity is n log n. Yeah, as you can, because this is a sort n log n time, and this is O n, and here is the bisector right, another log n time. So the time complexity is n log n, and it is exactly designed for this time complexity because n is 10 to the power 5. I think that's all about it. and thanks for watching. See you next time.